Good morning. So today we are going to discuss about two-point problem and triple problem. So in a two-point problem, don't worry, I have not started yet. Okay, I just waited for 2 or 3 minutes. So in a two-point problem, that is done to establish a new point. That means suppose if there are some complication of plane table traversing, then it may be noticed that an important object has not been located due to oversight. Okay, if no station pegs are found on the field, some special methods of resection are applied in order to establish a new station for plotting the missing object. So to find the missing object, suppose uh, in one day, suppose you have plotted 2 points. Okay, you have plotted P and Q. But suppose after plotting these 2 points P and Q, it was started raining. Okay, raining and it is about to say sunshade. So what happened? You just all pick up all the tables and instrument and you went to home, isn't it? And in the next day, when you come to the field, how you how you find these 2 points P and Q? So you have to uh, find this missing point. Okay. For this purpose, we do 2 point problem. So in this problem, two well-defined points whose positions have already been plotted on the plan are selected. Then, by perfectly bisecting these points, a new station is established at required position. Suppose P and Q are two well-defined points whose positions are plotted on map as P and Q, isn't it? It is required to locate a new station at A. So it is required to find a new station A. P and Q is already plotted. Okay. So A by perfectly bisecting P and Q. So we have to find a new station A which is bisected through these 2 points P and Q. An auxiliary station B is selected. So for this purpose, we have selected an ordinary station, auxiliary station B, and is selected at a suitable position. The table is set up at B. So what you have to do? The table, plain table, you have to set up at point B and leveled and oriented by eye estimation and then clamped with the LED touching small p and q. So from B station, you have to bisect P and Q. The points P and Q are bisected and rays are drawn. Okay. Suppose these rays are intersect at B. See, these P and Q, these are the 2 points, and B is a auxiliary station where you have to set up the plane table. And P and Q is bisected. Suppose this is P, draw a line P and PB and BQ and join this line, okay, and it will bisect, isn't it? So next, with the validate center on B, ranging rod at A are bisected and razor drawn. Then by eye estimation, a point A1 is marked on this ray. So we have to find a new point A. Okay, so you just put your ranging rod at A, and in the table you draw a line from B, you draw a line from A, and suppose it is 50 meter, so you draw a suitable scale. In the plane table you draw BA. The table is shifted and centered on A. Then what you have to do? You have to shift the table to A station. Okay, and the table is shifted and center on A with A1 just over A. It was leveled and oriented by backsighting. So you have to orient the table by backsighting. With the LED touching at point P, the point P is bisected and a ray is drawn. Suppose these rays intersect line BA at point A1 as was assumed. See here in this figure, the table is shifted at A position. Okay, P, this triangle is already drawn here, isn't it? BA is already, we have got the distance. How you find BA? From this position, you measure the horizontal distance, put a ranging rod on station A, and you plot this distance. Suppose 10 centimeter, isn't it? That is how we find BA1. Then we have to shift this plane table to station A, and you have to orient the table. Okay, you have to move the table so that PQ, so that the A is bisected through P and Q. Okay, and draw a line which bisect these two lines. It will be R, and join this line. You will get this station. The table is shifted and centered at A with A1 just over A. It is leveled and oriented by backsighting with the LED touching P. The point P is bisected. Okay, we have to bisect with elided, small p with p, and a ray is drawn. Suppose this ray intersects line BA1. BA1. With this BA1 line. Okay, as it was assumed. With the elided centered on A1, the point Q is bisected and the ray is drawn. Suppose this ray intersect the ray BQ at a point Q1. So the triangle PQQ1 is known as triangle of error. Which one? PQQ1. In the figure, it is PQQ1. P, this one. P Q, Q1. This is your error angle. Okay. Known as the triangle of error is to be eliminated. LED is placed along the line PQ. So you place the LED along the line PQ. PQ1. This P and Q1. You place this LED. Okay. Through this line. And the ranging rod R is fixed at some distance. And you hold the ranging rod at a distance R. Then the LED is placed along the line PQ and the table is turned to bisect R. So then you have to rotate the table in such a way so that R is bisected. Okay. R is bisected. Then the LED is placed along the line PQ and table is turned to bisect R. At this position, the table is said to be perfectly oriented. So finally, with the LED centered at P and Q, the points P and Q are bisected and razor drawn. Suppose these razor intersect at the point A, it would be present the exact position of required station. Then the station A is marked on the ground. So I will share one video link. With the help of that, you can understand how 2-point problem is done in the field. Okay. And next one is 3-point problem. So here we have taken 3 well-defined points. In 2-point problem, we have taken 2, but here we have taken 3 well-defined points whose distance are measured, whose positions are already been plotted on the map. Then, by bisecting these 3 well-defined points, a new station is established. No auxiliary station is required in order to solve this problem. The table is directly placed at the required position. The problem may be solved by following method. One is Bessel's method, mechanical method, and trial error method. So for 3-point problem, for solving 3-point problem, we have 3 methods. So Bessel's method, mechanical method, and the trial and error method. Okay. The 3-point problem, the graphical method or Bessel's method. Suppose A, B, C are 3 well-defined points which have been plotted as A, B, C. Now it is required to locate a new station P. Okay. So ABC is already known, already drawn in the plane table. We have to find a new station P. The table is placed in the required station P. So what we have to do, we have to place the table at station P and level the LED is placed along the line CA and the point A is bisected. The table is clamped with the LED center. See, the point B is bisected and the ray is drawn. So from position A, we have to bisect all the points. See, this is your first operation, this is your second operation, that one is third operation. So in first operation, this A, B, and C are these 3 points, and this distance is known. Okay. Then this is your second operation. You bisect C point, and this is your diagram in your uh, drawing sheet. In plain table, there is a drawing sheet, isn't it? In drawing sheet, you have to draw all the rays and you have to do all the measurements, isn't it? So then you set the table at point P. So from point P, these are the 3 points ABC. How ABC is marked? Ranging rods are plotted here. With the ranging rod, we have to mark the station. Okay. Then you ACD, A C D. You have to bisect A station from this point and draw a line AP and AC, AD like that. Okay, and it will intersect at one point. All three positions from P you have to intersect. You have to bisect, and at D point it will intersect. The LED is placed along DB and the point B is bisected. At this position, the table is said to be perfectly oriented. Now the rays A, B, B, C, C are drawn. These rays are must meet at a point small p, which is the required point on the map. So this point is transferred to the ground by U4 and plumb bob. So uh, in 3 point problem, only you have to do is you have to find a position P in your drawing sheet. And that is found out by bisecting method, by drawing rays from three well-defined points ABC. So this is a very easy method rather than 2 point problem. Okay. And 3 point problem, this mechanical method is given here. So you study yourself all these three mechanical methods. You study yourself, okay? And points to be kept in mind in plain table. The first service station and the scale of the map shall be chosen that the entire area can be plotted on the paper. While establishing magnetic north on the paper, using trough compass, things causing local attraction shall be kept away of the table. The plain table should be clamped after centering the level. After centering and leveling, the table should be rotated at the time of orientation. And errors in plain table. The various errors, it may be instrumental error, it may be error due to manipulation, errors in plotting. Okay, these are the instrumental errors. Surface of drawing board is not plain. The edge of the LED is not straight. The object van and side van are not perpendicular to the LED. The edge of LED is not parallel to line of sight, and fixing clamp is not proper. So these are maybe the errors. Errors in manipulation, defective leveling, defective tightening, defective orientation, defective centering, movement of board. And these are maybe some questions from plain table. List of explain the method of intersection method of traversing, explain the method of intersection, principle of plain table survey, limitation of plain table survey. Okay, so basically you have to give exam in MCQ, that is the questions will come in objective form, so there is no subjective questions in your final semester. Okay, only MCQ you have to solve and practice. And probably your exam timetable will come out soon. And maybe your exam is from, that means in the month of last week of your July. Okay. So only one month is left. So let's move to the. I will share these notes, okay? I will share all the notes to you. Today I will share. And next, can we start the theodolite? So let's go to the theodolite. Mute myself. So this is your theodolite. It has one vertical axis and one horizontal axis. With which a theodolite with vertical axis and as well as horizontal axis, both direction. Okay. So because of these various uses, because of the uses of theodolite in various purpose, it is known as universal instrument. Okay, and there are different purpose for which theodolite can be used. Suppose to measure some horizontal angles, to measure vertical angles, to measure deflection angles, magnetic bearing, measuring of horizontal distance between 2 points, finding the vertical height of an object, finding the difference of elevation between various points, and ranging a rod. All these can we all this work we can do with the help of theodolite. Okay, and theodolite may be two types. One is your transit theodolite and another may be non-transit theodolite. So in transit type, the theodolite can be moved, revolved through a complete revolution about its horizontal axis in a vertical plane, and in non-transit the telescope cannot be revolved through a vertical plane. Okay. So far we have been measuring horizon angles by using compass, isn't it? So we have we have used compass. We have to find out the bearings of the angle, isn't it? Which is less accurate, and it is not possible to measure vertical angles with a compass. So, with the object there are at a considerable distance or situated considerable elevation and depression, it is necessary to measure horizontal and vertical angles more precisely. So, these measurements are taken by an instrument known as theodolite. Okay. The system of surveying in which the angles are measured with the help of a theodolite is called theodolite surveying. The theodolite is most accurate surveying instrument, mainly used for, already I have told you, for measuring horizontal angles, locating points, prolonging surveillance, finding difference of levels, setting out grades, ranging curves, and tachometric survey. Next, transit vernier theodolite. These are the different parts. Can you see? These are the different parts of a theodolite. Okay. In the lower side, it is a tripod leg, tripod head, and tri-weight. Okay. This is the leveling screw. These 2 points are leveling screw. This is the vertical axis. This is your object van. This is your telescope. Okay. And this is your altitude bubble, vertical clamping screw, trianion axis. This one. Trianion axis. This is your vertical circle. This is your eyepiece. This is your plate level. This one is upper plate, vernier, AB lower plate, inner spindle, outer spindle, tri-back. And this is your leveling head. Okay. So these are the different parts of a transit theodolite. Details of upper and lower plates. So in this figure, the details of upper and lower plates are showing. Upper clamp, lower plate, upper plate, transit vertical theodolite. So these are the axes through which you can rotate a theodolite. This is your vertical. Let me show in it's red color. This is your vertical axis. This is your horizontal axis. This is your telescope. Okay. This is your eyepiece. And this is your objective. Object you can see through this lens. Okay. So the angle which is made with the telescope with vertical axis, that is your vertical angle. This is your vertical circle. And this is your horizontal angle. Horizontal circle. Okay. So both way we can rotate the theodolite in this direction also and in this direction also. Okay. Classification of theodolite. One is your transit theodolite. Normally we in your laboratory we use transit theodolite. Okay. Transit theodolite, non-transit, vernier and micrometer theodolites. Transit theodolite it can be rotated, revolved through a complete revolution about its horizontal axis in a vertical plane, whereas in you can write your enrollment IDs in chat box. And where in a non-transit type, the telescope cannot be transited. They are inferior in utility and have now become obsolete. Okay. Classification of theodolites. This is the classification of theodolite vernier micrometer. Vernier theodolite for reading a graduated circle. If verniers are used, the theodolite is called vernier theodolite. Whereas a micrometer is provided to read the graduated circle, the same is called a micrometer theodolite. Vernier and theodolite are commonly used. Size of a theodolite. The theodolite is designed by diameter of the graduated circle on the lower plate. The common size are 8 centimeter to 12 centimeter, while 14 centimeter to 25 centimeter instruments are used for triangulation work. Greater accuracy is achieved with larger theodolite as they have bigger circle with larger divisions, hence used where the survey works require high degree of accuracy. So these are the different transit theodolite consists of these parts: leveling head, lower circulated plate, upper plate, telescope, vernier scale, T-frame, plumb bob, and tripod stand. After that, let me see. So different terms are given here. Definition of different terms. What is the time? 9:50. So we can. Terms used in manipulating a transit vernier to light centering. Suppose these are the terms which is used in field light survey. Centering. What is centering means? Centering means setting a field light exactly over an instrument station so that its vertical axis lies immediately above the station mark. Okay, that is your centering. It can be done by means of plumb bob suspended from a small hook attached to the vertical plane. The center of shifting the arrangement is provided with the instrument helps. Let me show. Okay, just wait for a while. Okay, so the center of shifting arrangement, if provided to instrument, helps easy and rapid performance of the centering. Next, transiting. What does a transiting mean? Transiting is also known as plunging or reversing. It is the process of turning the telescope about its horizontal axis. Okay, if you move the telescope about its horizontal axis, then it is called transiting. Okay, a true angle 180-degree in the vertical plane, thus bringing it upside down and making it point exactly in opposite direction. Swinging the telescope means it means turning the telescope about its vertical axis in horizontal plane. If you turn the telescope about that is vertically, that is your swinging. A swinging called right or left according as the telescope is rotated clockwise or counterclockwise. Okay. Face left. If the vertical circle of the instrument is on the left side of the observer while making a reading, the position is called face left. The same face, changing face. Okay. Another important term is your line of collimation. It is also known as the line of sight. When you are seeing some object through eyepiece and objective, then it is your line of collimation in the through the telescope. Okay. It is known as the line of sight. It is an imaginary line joining the intersection of the cross hairs of the diaphragm to the optical center of the object glass and its continuation. Axis of telescope. It is also known as imaginary line joining the optical center of the object glass to the center of eyepiece. Axis of level tube. It is called bubble line. It is a straight line tangential to the longitudinal curve in the level tube at the center of the tube. It is horizontal when the bubble is in the center. Term used in manipulating a transit vernier to light vertical axis, horizontal axis. Yes, this one is important. Adjustment of feature light. How we can do adjustment? There are two types of adjustment in etude light, and is one is your permanent adjustment, and next one is your temporary adjustment. What does a permanent adjustment means? The permanent adjustments are made to establish the relationship between fundamental lines of the theodolite, and once made, they'll last for a long time. They are essential and for the accuracy of observations. Then adjustment of a theodolite, permanent adjustment. How can you do permanent adjustment? Adjusting horizontal plane level, collimation adjustment, horizontal axis adjustment. Okay. Adjustment of telescope level to the altitude level, vertical circle index adjustment, and temporary adjustment. What are the temporary adjustment? Centering, leveling, and focusing. And measurement of horizontal angles. There are three methods of measuring horizontal angles: ordinary method, repetition method, and reiteration method. Okay, next class I will discuss. Okay.